Welcome back everyone, Patrick here, and in this next example we're told the formula for the surface area of a rectangular prism is 2WL plus 2WH plus 2LH, where the W is width, the L is length, the H is height. And for a cylinder, it's 2 pi r squared plus 2 pi r h, where the r is a radius and then the h is a height. And what we have to do is we have to write both of those formulas in factored form and then confirm that they're equivalent to the original formulas with actual values, with actual width, lengths, and heights for the rectangular prism, and with an actual radius and height value for the cylinder. So let's start off with the rectangular prism. So we know the surface area is 2WL plus 2WH plus 2LH. And what we got to do, we got to factor this over here. So what can we factor from all these? Well, notice we could definitely take out a 2, and that's actually all we could take out because none of these three expressions contain the same variable. Here we have a W, here we have a W, but here we don't. Here we have an L, here we don't have an L, but here we do. And then over here with these two we have an H, but over here there's no H. So we could only take out a 2 from all three of these, and when we do that, divide this by 2, divide this by 2, divide this by 2, what would we be left with? WL plus WH plus LH, like that. Right? So this here is the factored form for the surface area of a rectangular prism. And now what we got to do, we got to make sure that both of these formulas are equivalent, that they're the same using actual values. So you could pick any values you want. Let's I'll pick the width to be 3. You can put centimeters or meters. I'm just going to leave it unitless. So we'll have W is equal to 3, we'll have L is equal to 4, and then let's have the height equal 5, like that. So if we plug these in over here, what would we end up with? We'll have 2 times the width, which is 3, times the length, which is 4, plus 2 times the width, which is 3, times the height, which is 5. Right? I'm just taking these, plugging them in here, and then plus this last expression, we'll have the length, which is 4, times the height, which is 5, like that. Right, now we just have to simplify this. So let's do the multiplication of all these. 2 times 3 is 6, times 4 gives us 24, plus 30, plus 40, like that. And so we would end up with a surface area of 94 units squared. Right, if this was in centimeters, this would end up being centimeters squared. Area is always whatever units you're dealing with squared. Okay, so that's what we get. We get 94 for these values of a rectangular prism in the original formula. Now what if we use these same values in our factored formula? So we'll have 2, the width was 3, the length was 4, plus the width was 3, the height was 5, plus the length was 4, and then the height was 5. Like that. So now we got to work with this big bracket first. So we'd have 2, and then over here 12 plus 15 plus 20, and then work with this bracket. We'd end up with what? 27 plus 20, which would give us 47, and then 2 times 47 would give us 94, like that. So notice that we do get indeed the same surface area. So we could be fairly confident that this factored formula for the surface area of a rectangular prism is correct. Now what about the cylinder? So the cylinder, do the same thing. We'll have the surface area of a cylinder is given as 2 pi r squared plus 2 pi r h, like that. Now, what can we factor from this? We could definitely take out a 2 again, but notice now, both of these expressions, they have common variables. So we could take out 2. We could also take out a pi, which is just a constant, but it's common in both. So we could actually take out a 2 pi. And then notice that the variable r for the radius is common in both. And when we have that, we always take out the lowest exponent. Here we have an exponent of 2, here we have an exponent of 1. So 1 is the lowest exponent between those two. So we could take out an r to the power 1 or just an r. And then an h we can't take out because even though it's here, it's not in this expression over here. In order to take out a variable, it's got to be in all the expressions. And so what would we be left with in this bracket? Let's do this on the side here. What we do is we take out or divide whatever's there by that greatest common factor we're taking out. So that would be this expression. Then we'll have 2 pi r h over 2 pi r. And then there's a plus in between there. So notice the 2's cancel out, the pi's cancel out, r to the 2 over r to the 1, subtract the exponent, so we'll have r to the 1, which is just r, plus 2's cancel out, pi's cancel out, the r's cancel out, and we're just left with an h. So what we're left with in the bracket is just r plus h. So this is the surface area for a cylinder. This is also the surface area for a cylinder, just in factored form. We took out that greatest common factor of 2 pi r. So now what we want to do is check that both of these are equivalent with actual values, and the two characteristics for a cylinder that we need is the radius and then the height. So let's maybe, again, you can use whatever values you want here. Let's use 3 for the radius and then 5 for the height. So if we plug that into the original, we'll have 2 pi, the radius is 3, squared plus 2 pi, the radius is 3, the height is 5. And you can get the decimal values if you want, because this pi is like 3.14, etc., etc. So if you use your calculator, you can get the decimals. I'm actually going to keep it as exact values. So I'm going to keep that pi there. So here, notice we have an exponent. We got to work with the exponent first. So we'll have 2 pi times 9, right? 3 to the power 2 is 9. And over here, we can multiply all these. 2 pi times 3 times 5, 15 times 2 is 30. So we'll have 30 pi right there. Over here, we'll have 18 pi. And then notice these are like terms. That'll just be 48 pi like that. And I'm going to leave it like that as an exact value. If you want, you can get the decimal in your calculator. Now, let's see if we plug in this over here, if we get that same value. So we'll be taking 2 pi, the radius is 3, and then over here we'll have 3 plus 5. Here, 2, 3, 6 pi. Here would be 8, like that. And then notice 6 pi times 8 does indeed give us 48 pi. All right, so notice that we get that same value with both of our formulas, so we could be pretty confident that that's the correct factor form.